Assalamu alaikum students. Today we will study the next interpolation technique, and that interpolation technique of the Lagrange interpolation is Newton's divided differences. And with the help of divided differences, we will calculate the Newton's interpolating polynomials. So first of all, when the function values are given at non-equispaced points, we have developed the Lagrange interpolation formula. Newton's divided difference formula has the same accuracy as the Lagrange formula. It has the advantage of being computationally economical in the sense that it involves less number of arithmetic operations. So now how to find out the divided differences, let's assume that we have to construct, for example, we have the points x is, we have, for example, we have points like 5 points, and 5 points are x, and that is called x0, x1, x2, x3 and x4. So these are 4 points and 5 points, and if the function is given, then we have to calculate, and if the function is not given and the directly y points are given, then we have the points y0, y1, y2, y3 and y4. So the basic concept of the divided differences is that a divided differences is basically this kind of a 2-point slope, like y2 minus y1 divided by x2 minus x1. So these are basically, it has the differences, and they are in the quotient form, that is called divided. So first order divided differences are calculated. So I hope that you got my point, and that is why that involves 2 points, x0 or x1. So divided differences are calculated as y0 minus y1 divided by x1 minus x0. So this is first order divided differences, because these are differences like rise over run. So these are slope, kind of a slope, and because these are divided, so differences are divided. So that is my point. Okay, so when we want to calculate it, I would say that this one is, let it be m1, because that is a constant. So let it be m1, and if you want to calculate the divided differences between y1 and y2, then it is like that: y2 minus y1 divided by x2 minus x1, and let it be m2. And also y3 minus y2 divided by x3 minus x2, and let it be m3. And the last first order divided differences is y4 minus y3 divided by x4 minus x3. So that is equal to m4. So these are the first order divided differences between the two consecutive points. Now in the next column, let us calculate the second order divided differences. So second order divided differences should be between m2 and m1, and that is equal to, that involves basically 3 points, x0, x1 and x2. Now the domain is increased between the 3 points, and that is b, let it be rise over run, and that is m2 minus m1 divided by, now the frame of domain is increased between x1, x0 and x2. So that means final point minus initial point, and final point is x2 and initial point is x0. So this is how the second order divided differences will be calculated, and let it be d1. Okay, that will be a constant. Okay, now to find out the divided differences second order between m3 and m2, that will be m3 minus m2 divided by, now your domain is increased between x1 and x3. So last point is x3 and first point is x1. So that it is d2. Okay. And similarly between m4 and m3, that is equal to m4 minus m3 divided by x2 and x4, and that is equal to d3. Okay, now we proceed further, and we have to calculate the third order divided differences. The third order divided differences can be between d1 and d2, and that is equal to y of x0, x1, x2 and x3. Okay, so this is equal to d2 minus d1. Now your domain frame has increased from 1 x0 to x3. So last point is x3 and first point is x0. So let it be equal to s1. Okay, so next divided differences, second, third order divided differences should be d3 minus d2, and now your domain frame should be between x1 and x4. So last point is x4 and first point is x1. Okay, let it be S2, and then the in this case, in the 5 points, you have the last is divided differences should be of fourth order, and that should be between S2 minus S1 divided by the time. Now the domain frame is between x0 and x4, so x4 minus x0, let this point be a P, and then your divided differences of 5 points will be up to the point P. So it depends how many points you have, and then you proceed further until you get a single point or single constant of that. So this is the step number 1, to calculate the divided differences between the two consecutive points and further move on further. Okay. Now the second step is that you have to assign the coefficients. The assignment of coefficients is that you have in the first row. Okay, one more thing I have to tell you, that there are two types of divided differences, that is forward divided differences and backward divided differences. So in this we will calculate the forward divided differences. So we assume the first, these are columns, and we assume the first row in that. So in the forward divided differences. So step number 2 is you have to assign the coefficients. So in the first row, this all is first row. So let y0 is equal to a0, and let m1 is equal to a1, let d1 is equal to a2, let s1 is equal to a3, and let p is equal to a4. So this is the assignment of the coefficients. Now this next step is you have to calculate these divided differences and then coefficients, and you have to apply these all things in the Newton's interpolating formula. So Newton's interpolating formula is or interpolating polynomial. So let p of x or y of x is equal to a0. Now see the pattern: a1 x minus x0 plus a2 x minus x0 into x minus x1 plus a3 x minus x0, x minus x1, and x minus x2, to so on. Now the journal formula for this is an x minus x0. See the pattern behind that: x minus x1, x minus x2, to so on. If it is an, like this, if it is a3, then last point is x2. So if it is an, then last point will be x minus xn minus 1. So you have to apply all the values of x0, x1, x2, x3, and x4 in this formula, and also a0, a1, a2, a3, and a4 in this formula, and then at the specific point just apply the value of x, and then you can calculate the p of x, Newton's interpolating polynomial, by this. So in the next video we will solve example 40. Here is the example that find the interpolating polynomial by divided differences at point 3, and x points are 1, 2, 4, 5, 7, and y points are 52, 5, minus 40, and 10. Now let us construct the table, and the table is, let x this point and let this be, okay, and y points. Now x0 is equal to 1, x1 is equal to 2, and x2 is equal to 4, and then 5 and 7. So there are basically 5 points. Okay, and my points are given 52, 5, minus 5, minus 40, and 10. Okay, the first order divided differences will be 5 minus 52 divided by 2 minus 1. So that is equal to minus 47 divided by 1, that is equal to minus 47. And also minus 5 divided by 4 minus 2. Minus 10 divided by 2, and that is equal to minus 5. And also these 2 points, minus 40 minus 5 divided by 5 minus 4, that is equal to minus 40 plus 5 divided by 1, and that is equal to minus 35. And also 10 minus 40 divided by 7 minus 5. 10 plus 40 is 50, 50 divided by 2, and that is equal to 25. So these are the first order divided differences. Okay, the next column is for the second order. So the second order, now your domain frame is increased between 1 to 4. Between 3 points. Okay, so minus 5 minus 47 divided by 4 minus 1. And you know that minus 5 plus 47 is 42 divided by 3, and that is equal to 14. Okay, and then your domain frame is changed from these 3 points 2 to 5. Minus 35 minus 5 divided by 5 minus 2, and minus 35 plus 5 is minus 30 divided by 3, and that is equal to minus 10. Okay, so your domain frame is changed from 4 to 7. Okay, and then 25 minus 35 divided by 7 minus 4, and 25 plus 35 is, I guess it will be 60. So 60 divided by 3 is equal to 20. And then third order divided differences. Now your domain frame will be from 1 to 5. Okay, second order will be calculated as minus 10 minus 14 divided by 5 minus 1, and that is equal to minus 24 divided by 4, and that is equal to minus 6. Similarly, 20 minus 10 divided by 2 to 7, and 7 minus 2. So 20 plus 10 is 30. 30 divided by 5 is equal to plus 6. So these are the third order divided differences. And then last column will be of fourth order divided differences, and your domain frame will be from last point to first point. So 6 minus 6 divided by last point is 7, and first point is 1. 7 minus 1. So 6 plus 6 is 12, and that is equal to 2. So this is the first step, and now we will calculate the second step. Second step is the assignment of the coefficients. So let it be 52 y naught is a naught, minus 47 is equal to a1, that is m1, and d1 is a2, and minus 6 s1 is a3, and 2 is equal to a4. This is a very interesting method. I really like it, and it involves less number of iterations. Okay, last step is third step is Newton's interpolating polynomial, and that is equal to p of x. Now let us construct the coefficient and all the formula that involves the 5 numbers, and a naught plus a1 x minus x naught plus a2 x minus x naught into x minus x1 into x minus, okay, no, it's x1, okay, plus a3 x minus x naught x minus x1 x minus x2 plus a4 x minus x naught x minus x1 x minus x2 and x minus x3. So that's it. This is the formula, and you have to replace x0, x1, x2 and x4, x3, x4, and also a0, a1, a2, a3. So first step is that you have to replace this a0, and that is okay. Now we have to replace the values of a0, and a0 is equal to 52, and plus a1 is equal to minus 47, x minus x naught is 1 plus a2 is equal to 14, x minus x naught is 1, x minus x1 is 2 plus minus 6, x minus 1, x minus 2 and x minus 4 plus 2, x minus 1, x minus 2, x minus 4 and x minus 5. Okay. Last step is that the question is to find the interpolating polynomial by divided differences at point 3. So the reference point is 3. So you have to replace the 3 instead of x. So here instead of x you have to replace 3. So if you replace this 3 and you calculate this all formula, then it will be 6. Yes, it will be 6. The answer will be 6. So this is all about the Newton's interpolating polynomial by divided differences. And I hope that you understand. If you have any queries, you can ask me in the online lectures. Thank you so much.